Okay, so we're going to review how we use pointers in C to modify a value for a variable. And we will also see how we use pointers to pass by reference to a function. And then we will complete this example on how to use pointers with arrays to access the array and alter its content and or pass a whole array to a function and then alter it from there. Okay, so for this, we're going to need a compiler that can handle a C language. So Dev C++ will be a good one. We will start with, we will call this file pointer review. .c. I'll call it 1 since I'm going to have several programs to illustrate what we're doing. Okay, so as you can see, I'm doing C-style comments, and we're going to call this file pointer review.c. So I'm just going to copy this part here and hit save. Make sure that your extension is a .c. So go over here, and then for the file name, just paste that name that we wanted. Do I want it under this directory, midterm reviews? Yeah, sure. Okay, so this could serve as a midterm review if you're taking a C program course somewhere. Okay, all right, fantastic. So let's go ahead and start with our first program. Include stdio.h. And let's have our main function, which is sometimes referred to as the controlling function, return 0. Now for this particular compiler and the way it runs, you need a system pause to hold the screen, otherwise it will go way too fast. You're not going to be able to see any of your results. I can at this stage compile and run just to see what we get, and as you can see, the system pause basically brings in the press any key to continue from the operating system. This is coming in from the operating system. Okay, so this is why this is a function call, and this function happens to be called system. If you were in DOS and you typed pause, this is what you would get. So it's running the pause command for the disk operating system for this OS. Okay, I happen to be running Microsoft Windows on my virtual machine. Now let's get to the business of showing what a pointer does. First, let's understand the behavior of a regular variable. So let's suppose we had int data. So I've declared an integer type data variable called data. I can assign it a value, data equals, let's say 0. I can print its content, so we can do something like this, printf. The value assigned to data is equal %d/n, and that would be data, right? So we want to see that, so we can actually compile and run this part quickly to see that we're getting our 0, right? So everything looks good. All right, so next what we're going to do is go ahead and create a pointer that will point to data, and we will try to alter data via the pointer. So this will give us a good understanding of the behavior of the pointer vis-a-vis the variable. So first of all, if you want a pointer that will point to an integer data type, then your pointer better be of the same type. So if data was a float, then your pointer needs to be a float. If your data was a char again, then your pointer needs to be a char, etc., etc. So they have to match. Now a pointer, so this, now I could have put the asterisk next to the pointer variable, but I am going to put it right next to it. This is another form of showing what a pointer looks like. And I'm going to do, I'm going to call it DTPTR. Okay, now this pointer here, so this is a pointer declaration. It's not pointing to anything, right? So it's just by itself. You can't really use it for anything at this stage. It's not usable. So how do you make it usable? What was your intent? make a point at data? Great. So you go ahead and do data PTR equals the address of data. So this is the secret sauce right there. Okay, so this is what we call the pointer assignment. Okay, so if we assigned a pointer to now a variable, can we use the pointer to view the content of data? And the answer is yes, right? So just for giggles, let me go ahead and change this to 6, right? So we would like to see some other value other than 0, okay? And let's go ahead and do a printf. And oops, need to go, I just like to line it up with everybody else. So printf. And then the value pointed to by the pointer equals %d. Now what you need to do, you need to dereference the pointer to access the value pointed to by the pointer. So how do you dereference a pointer? You put an asterisk next to the pointer variable, dtptr. This shows you where it's pointing at. Well, let's see if that is true. So let's compile and run. And sure enough, the value assigned to data is 6. The value pointed to by the pointer is equal to 6. So I'm keeping it simple. I'm not showing addresses or anything of that nature. In a formal course, I'll go a little deeper. Right now, we just need to understand the utilization of a pointer and what it can do for you. So I'll take it, however, one step further. Can I alter data via the pointer? And the answer is absolutely. And that is one of the reasons we like to use pointers. It's because we can alter a variable remotely. And that will become more important later on when we have function calls and we want to pass by reference. That will be our next example. So for now, can I still do or access data and alter its data using this pointer? And the answer is absolutely. So the way to do it, again, you need to dereference the pointer, dtptr, and then, okay, we'll assign it a value. Let's say -5, right? Let's see, and this time I'm just going to print data directly and see if its content got altered. So printf, the value of data after altering it using the pointer. Just do an equal here, %d /n. Let's see how it behaves. And that would be data. Just show me data. Okay? All right, so let's do that. So compile and run. And there you go. As you can see, the value of data after altering it using the pointer equals -5. Okay? So the pointer, dtptr, allowed us to alter data since we had full access to that memory location. Okay? As I mentioned before, everything is right here. This is where the magic happens. Okay? So once you assign the address of data to that pointer, you have full access to it. So this is this one. So now let's look at the next step on how to use pointers to pass by reference. So a good comparison is to show what we mean by passing by reference versus passing by value. And in either case, that will give us a good idea on how to compare these two concepts and understand how memory is accessed.